Something changed under El Salite before the people living there had any reason to fear the ground beneath their homes. At first, it looked like one of those strange local incidents that people talk about for a few days and then try to explain away. A patch of earth suddenly broke open. Mud, steam, and hot water forced their way
hot
up through
mud,
the
and
backyard.
sulfurous
Not in the
gases
middle of a marked
burst
geothermal
through the
zone,
earth.
not behind fences, not near a tourist hot spring where warning signs remind visitors that the soil is unstable. This happened where people lived, a place where animals were kept, a place where families moved through their day without thinking that heat, pressure, and boiling mud could be building just beneath their feet. Then came the second opening, and that is where this story changed.
Name
One vent
roughly
can be
translate
treated as a rare
to
pressure release.
Eastland of the
Dangerous,
Boil.
yes, but possibly isolated. A second vent in the same community is harder to dismiss. It raises a much larger question, not just what happened in one backyard, but what is happening beneath the village itself. El Salitre sits in a region of Mexico where geothermal activity is not a mystery. Hot water, sulfur odors, old hydrothermal features, and nearby thermal areas have long suggested that heat exists below the surface. But there is a major difference between a known geothermal region and boiling mud breaking through residential ground. That
Deep
difference
into the earth through
matters.
faults and fractures.
Geothermal activity
Think
does not mean every house is sitting on the edge of disaster. It means the ingredients exist below heat, water, gas, pressure fractures, and pathways through the rock. Most of the time, those ingredients stay balanced. Water circulates quietly underground. Heat rises slowly from depth. Gases escape through familiar routes. The surface looks calm, and life continues above it. But in a hydrothermal system, calm ground can be misleading. The danger is not always visible before it announces itself. That is why the second vent is so important. It suggests the pressure may not have found one
1943
accidental
and
weak
grew
point. It may
dramatically
be
over
moving
several
through a wider
years.
network looking for several ways out. After the first rupture, fear spread quickly. Was this a new volcano? Was magma rising under the village? Could the ground open further? Those questions are understandable. When hot mud and steam blast out of the earth, it looks volcanic. It feels volcanic. To anyone standing nearby, the difference between a volcano and a hydrothermal eruption may not matter very much in that moment. But scientifically, the difference is critical. Specialists who examine the area have not described this as the birth of a new volcano. There is no
Most
confirmed evidence
famously,
that magma is rising to the
Peregrine
surface beneath the
volcano.
village. What they are pointing toward instead is a hydrothermal mud system, a system driven by hot water, steam gases, and mud under pressure. That is not harmless. It is simply a different kind of threat. A volcanic eruption usually involves magma moving upward, breaking rock, releasing gases, and in some cases reaching the surface as lava ash or explosive material. A hydrothermal eruption works differently. It can happen when underground water becomes superheated, pressure builds, and hot fluids suddenly find a path upward. What reaches the surface may be steam, boiling water, clay-rich mud, and gas rather than magma. In plain terms, this is less like lava rising from below and more like a pressure system losing containment. And pressure systems can be unpredictable. They do not always release from the same place twice. If one pathway clogs, pressure can shift. If a fracture opens, hot fluids can migrate. If ground weakens, another vent can appear. If a shallow cavity expands or collapses the surface, above it can crack without giving much warning. That is the part residents cannot afford to ignore. The visible hole is not always the full danger zone. Reports from the area indicated multiple mud pools or vents, including several inside the original property and more on neighboring land. That changes the risk picture. A single opening is alarming. A cluster of openings suggests something wider is happening below. This may not be one broken pipe, one water leak, or one isolated pocket of steam. It may be a shallow hydrothermal network moving through fractures under the community. Some temperatures were reportedly close to 86 degrees Celsius, about 187 degrees Fahrenheit. That is not warm ground. That is water hot enough to cause serious burns. Splashes can injure people. Animals can be burned. Soil can soften. Foundations and walls can be undermined if hot water and steam keep eroding material below the surface. Around a vent, the crust may look solid from a few steps away, but heat and moisture can weaken it from underneath. That is where many hydrothermal injuries happen. Not because someone falls into a dramatic crater that looked obviously dangerous, but because they step onto ground that appears safe and the surface gives way. A thin crust over boiling water is still a trap. That is why local warnings matter. Stay away from the openings. Keep children back. Move animals out of the danger zone. Avoid cracked ground, wet, hot soil, steam, and unusual warmth at the surface. These are not overreactions. They are the basic rules of survival around unstable hydrothermal ground. The dramatic image is the mud shooting upward. The real threat may be quieter. Heat hollowing the soil, steam moving sideways through cracks, gas collecting in low spaces, ground softening where no open hole has appeared yet. A backyard can still look like a backyard until the moment it stops behaving like one. At American Sky Brief, this is the part we pay close attention to, not just the visible eruption, but the process underneath it. The vent is the symptom. The system is the story. El Salitra's location gives us part of the explanation. The area already has the conditions needed for geothermal behavior, heat below groundwater moving through rock and fractures that can allow fluids to rise. In many geothermal regions, this activity remains stable for years. Hot springs bubble in known places. Steam vents stay where people expect them. Locals understand which areas to avoid. But new vents inside lived-in spaces are different. They suggest the system has changed at the surface. That change could have several causes. Underground water flow may have shifted. A pathway may have become blocked. Pressure may have been redistributed. A fracture may have opened more fully. Seasonal groundwater changes, small geological adjustments, or pressure buildup inside the hydrothermal system could all play a role. Those are possibilities, not confirmed conclusions. The confirmed concern is simpler hot pressurized material has reached the surface in more than one place. That is enough to take seriously. The first rupture showed that pressure found one weak point. The second showed that the system may have more than one active escape route. The discovery of additional mud pools makes the situation harder to treat as random. It suggests a broader, shallow disturbance, not necessarily a large disaster, but a local hazard with real consequences for the people living above it. This does not mean the whole village is about to collapse. It does not mean a volcano is rising in the middle of town. Those claims would go beyond the evidence. But it does mean the ground cannot be treated as normal. The risk is not only what has already opened. The risk is what could open next. In a worse realistic scenario, new vents could appear near walls, courtyards, animal enclosures, or rooms where people sleep. Hot mud could spread across patios. Boiling water could pool in low areas. Steam could enter enclosed spaces. Irritating or toxic gases could accumulate where ventilation is poor. The ground around homes could weaken enough that ordinary movement becomes unsafe. That is a different kind of disaster. Not a towering eruption, not a wall of lava. A spreading pattern of smaller hazards that makes daily life impossible. Children cannot safely play on ground that may crack. Animals cannot be kept near hot mud. Families cannot ignore sulfur odors, new wet patches, or warm soil. Even if this never becomes volcanic in the classic sense, it can still force evacuations, destroy property, and leave residents uncertain about whether their homes are safe. Hydrothermal systems are powered by stored heat and pressure. Underground water can become superheated when trapped under pressure. If that pressure suddenly drops, some of the water flashes into steam. Steam expands with force. It can blast mud upward, widen cracks, and create new openings. If the vent remains open, mud and steam may keep escaping. If it becomes blocked, pressure may build again or move somewhere else. That is why these events can escalate without magma reaching the surface. Water and steam can do the damage on their own. So the central question is not simply, is this a volcano? The more urgent question is, why is this happening here now and in more than one place? If the activity stays limited, authorities may be able to cordon off affected properties, monitor temperatures, test gas levels, and keep people out of the highest risk zones. If more vents appear, the safety perimeter may need to grow. If gas levels rise or the ground continues to weaken, more residents may need to leave temporarily. If the system cools and stabilizes, the village may eventually return to a cautious normal. But that depends on monitoring, not guesses. Thermal imaging can help identify hidden hot zones. Gas measurements can show whether dangerous concentrations are building. Ground surveys can detect cracks, subsidence, or soft soil. Geological mapping can show whether known fractures align with the vents. Repeated measurements matter because hydrothermal systems can change from one day to the next. A single reading is not enough. The pattern matters. This is not a weather event, but the logic is familiar. In major storms, the visible clouds are only part of the system. In floods, the water in the street is only the final expression of what happened upstream. And in El Salita, the mud vent is only the surface signal of pressure, heat, and fluid movement below. That is why this story deserves caution without panic. There is no confirmed evidence that magma is rising to the surface. That is the reassuring part. But something hot, pressurized, and unstable is already reaching the surface in multiple places. That is the concerning part. For residents, the scientific labels matter less than the practical question. Which homes are above active pathways? How far do the fractures extend? Are gases being released at dangerous levels? Is the ground heating in places that have not opened yet? Is groundwater pressure changing? Are more vents likely? Those answers will take time. Until then, distance is protection. People should not approach the vents for photos. They should not walk across cracked, steaming, wet, or unusually warm ground. Children and animals should be kept away. Enclosed low spaces should be treated carefully if gas is suspected. And no one should assume a small opening is safe simply because it does not look dramatic. Hydrothermal ground does not need to look dangerous to be dangerous. El Salitre is now facing the kind of uncertainty that geothermal landscapes sometimes hide for years. A sulfur smell, a hot spring, or a nearby thermal field can become part of the background of daily life. People adjust to it. They stop thinking of it as a warning. But below the surface, water, heat, gas, and pressure are always interacting. Most of the time, the system stays contained. Sometimes it finds a way out. That is what makes this event so unsettling. It began not with a massive eruption or a regional emergency, but with one impossible opening in ordinary ground, then another, then more signs that the problem may not be confined to a single point. A backyard became a warning. A second vent became a pattern. And now a village has to ask, what has been moving beneath its feet? The next days and weeks will matter. If temperatures fall, gas readings remain low, and no new openings appear, the system may be losing pressure. If more vents emerge, if the ground continues to weaken, or if emissions increase, the danger zone could expand. Those are not predictions. They are the scenarios officials and specialists have to watch closely. This is the thin line between ordinary life and hidden earth processes. A stable yard, a small animal enclosure, a patch of wet soil. These are not places people expect geological danger to appear, but in a geothermal region, the surface is only the final layer of a much deeper system. And once that system begins opening new pathways, every vent becomes a clue. At American Sky Brief, we will continue following this carefully, not with hype and not with panic, but with the attention this kind of event deserves. Because the most important warnings are not always the biggest ones on the map. Sometimes they begin with one hole in the ground, then a second, and then a community waiting to learn whether the earth beneath it has finished speaking.